Good afternoon, everyone. I am Payal Bhag, MTTS head at IEEE SIS GST.
And I am Gaurav Patil, Technical Head at IEEE SSGST.
On behalf of the IEEE student branch of SIS Graduate School of Technology, I warmly welcome all of you to today's webinar on Smart BMS for electric vehicles, design challenges, and future trends. We are delighted to see such enthusiastic participation this afternoon.
So with the rapid advancement of electric mobility, battery management system or BMS have become one of the most crucial components in electric vehicles. They ensure battery safety, improve performance, and extend battery life, making them essential to the success of modern EV technologies. Understanding the design challenges and future in the smart BMS is extremely important for the student and professional aspiring to the work in electric mobility and power electronics.
Today, we are privileged to have with us an expert who is actively working in the field of EV systems and battery technologies.
It is our pleasure to introduce our speaker, Mr. Aditya Iyer. Mr. Iyer is a hardware and system integration engineer at Agrin Energy Private Limited. He has handled hands-on experience in system integration, hardware, bring about end-to-end validation of embedded and electrical systems. His expertise includes debugging, cross-function collaboration, and ensuring reliable system performance, particularly in the domain of battery management system.
We are truly honored to have you with us today, sir, and we look forward to learning from your industry expertise and insight.
With the further delay, I would like to invite Mr. Aditya to take over the session. Over to you, sir.
Uh-huh. Hi, yes. Uh,
Yes, you can.
Thank you for inviting me. So, uh, so, so my topic is on smart BMS for electric vehicle. Uh, 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 the design challenges and its trends means the upcoming trends. So uh, so I have been working at Eigen Energy as a hardware and system integration engineer. So I have a skill in system debugging, a hard, a hard, a hardware design, and cross-functional collaboration within the team. Uh, uh, so I- so my most of the experience is in the battery management uh, just system. So okay, so my focus would be to today just means uh, just to bridge the gap between the industry and the academia. So okay, so moving to the next uh, next slide. Ever have you ever wondered what um means why your phone is overcharging why and and why doesn't it go to a higher te- te- temperature? So means why means why doesn't it fail? So and and have you ever means thought like why does your EV car that doesn't stop in the middle of the highway? So so means the answer is the BMS. So uh, s- uh, so the so the BMS is the battery management system. So, uh, so it controls all the parameters and it monitors everything. Means based on the voltages current and the te- temperatures. So, uh, uh, so just to explain what is a battery pack, a, a, a battery pack is a series or a parallel a or a series parallel combination of cells. So of a of of similar types. So means there are various types of cell like LFP, NMC. So LFP stands for uh, the lithium iron of a phosphate, and the NMC are like nickel, nickel, cobalt, manganese batteries. So uh, 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 ha- so we arrange the cells in series and parallel co- combinations uh, to get different voltages uh, and amperes of the batteries. So in the next slide, I will like you to means show you like where does the BMS fit in the electric car. So it, it is at the floor it is at the floor side of the battery uh, uh, and and the BMS sits just above that. And then you can see over uh, here the various batteries arranged in series combination. So over uh, here is the bus bar. Bus bar is like the connection to individual cells or the battery packs. And then over over here is the output connector of the battery pack. So means over this can be like the high voltage positive and the minus side of the pack. So means over here we can see they have two of these, and this is the enclosure for the battery pack. So means sorry, within this our BMS is placed, and over here you can see uh, multiple wires coming from the cells. And then in the next line, with what uh, so uh, so there is two type of BMS in the market now. There 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 is the one simple one or the normal one, or and the other is the smart BMS. So uh, uh, s- so in the so in the normal BMS is like it it does the protection, and only just it means it just checks the value and turns off the switch or on. Means it turns on the switch if it is okay, and then and if there is any fault it will turn it off. So there is uh, a, so it is a simple like sample card or a simple electronics design. Okay, and then the core functions of a BMS is to do the over voltage, under voltage, over current, and the short circuit, and the temperature protection. Means it should not go above a particular set a particular set value. Like for LFP it is like 660 C to 2 minus 20 C. So means if it so So if it goes beyond that, it should turn the outputs off. Means it should not deliver the uh, deliver the pa- power to the load. And then and and then it can do also the passive balancing. So in that in that what is that, it take the energy and just convert it into heat, and then that does the balancing of the cell. So means the balancing is like uh, the cells are not equal voltage. uh, uh, so means after sometimes they create some imbalance in the cell. So that imbalance is very important. Means it will create means okay the end the result of this imbalance is a shorter is is shorter range to the car. Means you can drive a smaller means less kilometers means from that car. So we need to balance the uh, balance the cells. So in the means I mean so the how the how the simple or the normal BMS works. Uh, so what is uh, uh, has so what it does is that it takes in the voltage, converts it into some analog value, and then it it passes to the an IC. So that IC has a set value. So means after that voltage or after that current, it will trip. And then what does it mean to trip is like it will turn off the output as like uh, uh, the outputs are controlled by a switch. The 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 switch can be like MOSFET, a contactor, or or a or relay kind of thing. So it uh, means uh, uh, so that it can be built by an op-amp circuit or means like a MOSFET kind of kind of IC. Means uh, they are uh, they are kind of easy to build, and and the, and they do not have the advanced feature which we will see in the other smart uh, uh, other smart uh, BMS cards. So uh, s- uh, s- uh, so the issue with this card is that it uh, it cannot predict the health and the SOC. SOC is the thing that you see on your phone. Uh, that is like it is charged 100% or 50%. So SOC is the state of charge of the cell. So means how much capacity is left in the cell or in the pack. So uh, s- so so your simple BMS cannot do this thing. And then we have means it's like a reactive system. In case means like it just uh, uh, means it is like it has told some things to do and it will do that. It it cannot predict the output. Means 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 what will happen after some time based on the inputs. means if the cell voltage is going so high, so means what it should do next, and then and then it and and it doesn't have the connection to an app, a cloud, or the ECU. It means ECU is like ECU or okay, ECU is like electronic control unit inside the car. Means it okay. So means our simple BMS doesn't has this means the connectivity option also. So then we can so then we move to our smart BMS. So our smart BMS is an intelligence system. Means what we can do is like we can predict, analyze, optimize every parameter, and then the information uh, the uh, or the information like temperature, current can be current and voltage can be shared to a cloud by an IoT gateway, or it can be shared to the vehicle control unit or ECU through CAN LIN, um, and then it can also be shared to uh, 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 to to phones. Um, okay, and we can upgrade the so upgrade the firmware over this over the air. So it's like a 4 hour OTA update is available also. And then if we if we if we compare both the things, we can see our smart our smart BMS is intelligent, and we can do the analytics, the analytics of the data, which is not possible uh, in the simple uh, simple BM, BMS. And then we can also add some algorithms over the values. So means if like if it's not means it's just not like if this value is there, then trip. We can such that like if, if the voltage is going at this rate and the temperature is at this value, then do this. So means uh, so we have this kind of flexibility with this with the smart BMS. So and this okay okay. So over here is the overview of what makes a smart BMS smart. So means what we can say over here is like here is our normal BMS. So it's so it has a basic LED, just the temperature, current, and voltage strips, and the MOSFET drive or the contacted drive is present to turn off the outputs. So if we add up this feature with the smart BMS, so means we get everything over here. So it's like it has a main MCU that uh, that uh, that does all the jobs. So means it has the capability to do voltage, temperature, and current monitoring. Means it can actually take the data and then do processing over it. So and then we can do like thermal management is like if the if the temperature goes above this uh, means if the temperature goes above um, above some value, then turn on the um, pumps like coolant pump. So and then we can do like the the uh, the data can be stored into the SD card or a flash or a EEPROM. So means it has the capability to log the fault even also even uh, means like means after some time you can open the SD card uh, and then plug it into the PC and see and when and what kind of a fault has occurred. So and then it can do the SOC means means the means the SOC implementation and also the SOH. So the SOH is like is the uh, so the SOH is the state of health of the cell. It's like after some time this cell gets uh, dig, uh, dig I mean means the cell health goes down. Uh, so means the the smart BMS has the capability to also measure measure this kind of thing. And then what we also have an OTA update means if there is some change in the values or if if you want to move this card to other battery pack. So and then change the values of the voltage cutoff. So we can uh, we can do it through the OTA updates. And then one of the important uh, important part is also to the insulation monitoring of the vehicle. So it's like if uh, so uh, uh, so it is important as if there is the insulation of the buyers are getting the uh, getting broken due to some wear and tear. So we can we can get an idea of of what kind of what kind of damage has been there means what kind of uh, means what is the value of that insulation means how bad it has gotten. And then we can do the balancing of the cells. So means uh, so we have two kind of balancing now. One is the active and the other is the passive balancing of the cells. Uh, uh, okay, in the upcoming slide, I will explain that them both. Huh, yes, I know. And also we can add some extra inputs, extra inputs and outputs. So uh, so uh, over here here we can add some analog inputs, the digital input like switches and everything we can connect to. Huh. and and then if we move to the other slide, so we can see what is the simple BMS looks like. So we can see it has an IC, but it is uh, just to turn off the MOSFET and at at a certain value of the voltage voltage current and uh, temperature. So means it is okay. And then over here we can see that the, this is the example of a smart BMS. So so we can see over here that there is an MCU, the heart of the card means without without the MCU or the microcontroller unit, you means uh, you cannot sense the values of the cells or do any kind of thing. So and then we can see an art. Okay, we can see here a battery. Uh, this battery is used to log the time. Means it helps a circuit to store the time when the entire battery pack is off. And then over here you can see an uh, assembled card means into a battery pack, and then they and then they add a, a top lid onto that pack. Okay, in the next line, what we can see the estimate the SOC estimation can be done uh, in in various ways. So one of the most common ways is the uh, Coulomb count, counting, and then other is the Kalman filter. So in the Coulomb counting, what we do is we take in the current value and then integrate over a fixed time, and then you add it up uh, to uh, to uh, to to predict the current SOC of the cell. So on is how much charge is added or subtracted from the cell, and then the other is the Kalman filter. So means the in the Kalman filter, we use the probability to actually help us to give an uh, estimate based on the inputs like the voltage, temperature, and current of the cell to predict the to to predict the SOC of the cell. Uh, uh, the Kalman filter is a slightly uh, complicated type of algorithm, but it is used in the uh, uh, used in the industry, and it gives a better SOC estimation as compared to curriculum count. Curriculum count. And then we also have a model based estimation. In this, a model of the cell is created uh, into uh, MATLAB, and then based on uh, uh, and then based on that based on that model, the true SOC of the pack is 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 calculated, and then uh, a- and then we also have an AI assisted prediction model. I- in this case, what we do is we take the sample cycles of multiple cell and then give it to an AI engine, and that and then that AI engine will give a given predicted model of the cell, pre- pre- uh, uh, predicted model of the cell which can be which can uh, predict the true SOC of the cell. Uh, in the model based estimation, uh, we require the inductance. Means it's like the electrical parameter of the battery. So it's like so it's like we require the inductance, uh, the uh, the cell voltage and the re- 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 resistance of the cell, uh, and after getting this small these parameters, it is converted into the SOC. Sorry, it is converted into the model based estimation of the cell, and then from that we will get the SOC of the cell or a pack. And the next is the SOH. So the SOH is like the health of the cell. So over time, as we use it, the capacity of the cell, uh, the capacity of the cell goes down. So means uh, uh, so it's like the health of the cell is getting bad. So means we also require some kind of monitoring on that. We can do it like we can take the cycle of the cycle of the card. Sorry, the cycle of the pack, and then estimate the SOH of the cell. th- th- this is uh, one of the methods we can use, and the other is like uh, we can also use Kalman filter on that to get uh, a more or less accurate measurement of the SOH of the cell. Uh, uh, it is it means nowadays it is getting very important uh, to 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 predict the SOH of the cell is like because now we also have like cell swapping or a cell or a battery swapping technology technologies around. So means in that what they do is like they take your battery and then and then give give you a full charge battery. So means if we know the SOH of the cell, it is better, and we are assured that we will get uh, we uh, we will get a pack that is means that can last longer. Means it should not turn off in middle of a highway or a run. So so means the SOH is now one of the means like uh, trend, 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 trending things. So means and then what we means like and and then the smart BMS also offers an advanced cell balancing. So in this what we have like in this we can have like we can tell like the means do the balancing at this voltage uh, for a particular time. uh, means this kind of for flexibility we can get uh, uh, from the smart BMS. So means now there are two types of two types of balancing. So so one is the active, and the other is the passive. So uh, uh, so in the passive uh, balancing, what we do is like we take the excess energy or the imbalance in the cell, and then we convert it to heat through uh, re- 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 this uh, means like through a converter or something, and then in the active of what we do like means we take the energy from the imbalance cell, and then pass that energy to some other uh, cell in 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 this case we increase the increase the voltage of means like in in this we do not waste the energy of the cell and we charge the cell. Uh, this can be of two types. One can be of the means one can be like inductive and other is the capacitive. I mean means type of active balancing. The uh, the uh, the benefit of this type of means like the the benefit of the active balancing is like it is more energy efficient, but but it also uh, it but it also has a higher cost as compared to the passive balancing. And then now we get into the communication and the connectivity within the smart battery, uh, smart BMS. So means means we can and means we can take the data to CAN, LIN, UART, and BLE. So means all these are protocols with which means the means these means these are the hardware layer protocols. Means means they convert the information into the ones and zeros and which can be easily interpreted by your phone, by your servers, or or the IoT gateway or the vehicle control your unit, and then uh, and and then we can also have an OTA update over the air. Means like we can uh, we can send the update over the air, and then as soon as we connect some third party instrument to the vehicle, we can upgrade the firmware of the car or the smart BMS in this case. And 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 then we can also have like an analytics monitor over the cloud. So means we can uh, an, analyze the patterns. Means how the means how the driver is means taking the car. Means how is it means what is it means how means at at what current he rides. Means and what voltage are there, and are there any hotspots or the uh, or a particular cell is getting more stress. So means such kind of data can be monitored by this. Now in the smart BMS, what we have is like we have an sensor, we have an ADC, and then we have an MCU. So means all this all this information from the sensor are are taken into MCU, processed, and then if and and if there is a fault, it will trigger the fault, or else it will at the same time transmit all the information over CAN, wireless, IoT, Bluetooth, and anything. And then once we get this information, we can do some uh, uh, ex, uh, extra processing over the cloud, like sending no, no, uh, sending notification uh, to 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 the phone. Means um, to the user for identifying its uh, driving pattern, and and also give him suggestion on how to drive, means how to improve his driving, which will be better for the battery pack. Okay, now uh, uh, now in the means now it is like the smart BMS is just not, it's it, it's it's just not uh, not like the hardware part. It's like embedded. Uh, we have engineers working on the uh, firmware or the MCU such 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 side of the card, and then we have the pow- power engineers. So means uh, they do the high power system, means like how the how the things or the how the power converter should work to supply the energy to the other uh, different parts of the card, like like the MCU, the contactors, and everything. And then we have control engineers who 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 uh, who do the algorithms, means 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 who are continuously tuning the parameters to get the optimum values for the job. And then we have different type of, sorry, and then we have different type of protocol engineers over here. So so just to means like just so that the data can be transmitted from uh, from the card to the other instruments. And then we also have an we also have a like ML and AI engineers uh, 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 that uh, that also um, uh, that also they, they design the algorithms at the cloud end. So means like and 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 also they can build the models of the battery pack within the car. Means we can have a we can have a digital twin, like we can simulate that we can predict the behavior of the battery pack uh, in the field without actually uh, doing, means without actually running the vehicle. So means such kind of things is possible with the AI now. Okay, and then uh, now what are the challenges in the challenge in the hardware? So means uh, one of the most important challenges that we see is like voltage accuracy. It should be very accurate, and the current sensing. The 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 voltage sensing should be accurate because for the uh, LFP cells, the voltage band is very flat. So means means every millivolt can convert into 1% of your SOC. Uh, uh, it is slightly easier in case of NMC because it doesn't have that kind of steep or a flat SOC VOC curve. So 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 it is so the SOC so the voltage accuracy should be very good. and the other is the EMI no, 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 noise in the EV. So means we can see that uh, the electric vehicle uh, has multiple things, uh, li- li- uh, like more motors, the the air conditioners, everything produces non everything produces EMI non uh, noise into the vehicle. So EMI is like electromagnetic interference. So these noise can actually um, like means these noise can actually interfere with your car or the BMS in this case, and then it it can trip or it can give you the false values. So means uh, we need to design the system so that it should be very immune to this noise. Means it should be means it should not get affected by the noise. And then we have uh, now in uh, now we have like means in our means in the packs we have like 100 cells, 200 cells. So means we cannot actually place the temperature cell temperature sensing on the cells. Uh, so we actually place it in some particular areas just to get an idea of the means idea of this temperature of the cell. So means the issue with this is if some cell temperature is going above and and the sensor is not placed at that point, the effect will be very slow. Means after like 2-3 seconds, we will get that value, updated value. So so and then what we have is like this cell variation in the in means the cell to cell voltage variation and also the capacity is not exactly same. Means every cell is not is is not manufactured the same way. So means they have some tolerances in their like in their capacity and voltage. Means it is not always equal. And then in and, and then we have challenges in our algorithm side. So means SOC and SOH are one of the most important things uh, in the in the battery industry. If if we can predict this more, if means if we can predict this accurately, so it is means so means we can predict the actual range of the battery and also the health of the battery. And then we and then we also have some thermal instability. So means we should be able to like means we should be able to uh, design algorithms that are able to predict the instabilities, cell thermal instability. So uh, means there are cases like where the electric vehicle can catch fire. So means thermal runaway is is a case where it happens. So I mean uh, the temperature of the cell gets like increasing without any without any control. So means we should have an means we should have some algorithms uh, which are able to predict predict such kind of things. And then we also have means uh, the analog signals are not very means without any without any no means uh, without any no noise. So we should add some filtering. Means it can be hardware filtering or it can be a software filter. Uh, Software filter. So means uh, the uh, the the trade-off uh, the trade-off of using a filter is like it will delay this signal, but the signal will be very clear. So means we should have a means we have a trade-off in between how means at what speed this signal is being updated and how clear we want the signal to be. Okay. And then we also have means we also have system uh, system challenges. So means now we have uh, um, in an el- in an electric vehicle BMS we have like close to around 150 to 200 parameters just being monitored and being transmitted over the canvas. So, so means we should have a means we should have a processing capability to do everything at the runtime or the real time. So means so so we should write the code in such a uh, in in such a way that we can process means like 200 points means 200 parameters updating at a rate of uh, 10 millisecond or or even higher. So means we should be able to do all this uh, all this processing as fast as possible. And then and and then we should also do uh, uh, the uh, the the functional safety uh, functional safety compliance of the cards. Um, it should means it should adhere to the standards of ISO to 26 to 2062. And then now what we can see is the cyber security is of the most importance. Now now in the vehicle the canvas is like the uh, nervous system of the vehicle. So means if anyone tries to like get the access or through hardware or through software or through any way uh, of this of of the canvas. So means we can we can I mean means anyone can uh, hack this car. So means we should means we should develop some algorithms over that. Like it should means it means it should be protected against some cyber threats. And then and we also have the cost and the intelligence. So so as we increase the uh, intelligence in the firmware, hardware, or anything, the cost will go up. So means we should optimize our, our cost as per the requirements and as per the intelligence that we can provide. Okay, and then these are the few future trends. So means we can see that the AI AI algorithm for SOC and SOC and the SOH algorithm uh, is is one of the trending uh, trend, uh, trending things. And then we also have the wireless BMS architecture. In this, what we do is the individual BMS. So means we have in pack we can have two to three or even more BMS cards. So means all these cards are are not connected through wires, but through an wireless interface. It can be LoRa or uh, uh, or uh, it can be BLE or anything. So means hum, means by doing this, what we do is like we reduce the cost of the copper or the copper ca- cable. Means like for a 200 cell battery pack, we require 200 plus cells, cell ca- ca- cable. And then buying and and then by doing this, we can reduce the amount of copper. And then we can, okay. And then the next is we have di- di- uh, uh, digital twins of the battery pack. So means we can have like the uh, digital values. Means like it is like a digital copy of the original or the real battery pack in the uh, i- MATLAB. So means we can actually do like means we can do with various uh, uh, checks in the MATLAB. And then after getting a confidence, we can actually implement those algorithms or those things into our actual battery pack. Or then and 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 then after we have like uh, self-learning algorithms. So means it also and it also uses the AI to actually predict the um, health of the cell. And then one and then we also have an integration with the autonomous mo- uh, mobility. So means over here we can actually we can integrate our card with 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 different types of options. Like we can integrate it to inverter, say. And then or we can integrate to vehicle, or we can integrate to a smart homes. So means huh, and then we have the career paths which we can take. So means we can learn C, uh, embedded C for our MCU code, code, coding. And then we can use Python, Python for the AI and ML stuff at the cloud. And then we can use MATLAB to design the uh, to design the model of the cells. And then then the next is we can also do the control systems engineering and power engineering to actually get an idea of how it does. Means how we actually control things, and how we build the control systems around that thing. And then we also can explore into the CAN protocol. Means like CAN, LIN, UART protocols, which are which are the industry standards for means industry standards for communication between the with the vehicle. So means nowadays everything is being connected through Canvas. So means uh, uh, your mirrors in the cars, or your doors, or your uh, tail lamp, and everything is being connected with the cam. So means it is one of the most important and most used protocols in the automotive industry. And then uh, and then the and then the BMS, the smart BMS is a multi uh, disciplinary field. So means we also require mechanical engineers to actually build the enclosures to actually get means means actually give the means the uh, give the structural means um, give the structure to the car, means how it should be placed, and where it should be placed. So means everything is important. We also require thermal engineers. So means we should means we means so 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 that we can actually we can actually place our battery in specific locations. So I mean so that the heat is not gen so that the heat is not generated in the pack, or if it is generated, uh, we can take it out. So yes, and okay. Mm, yes, that's all for the means representation. Uh,
Hello.
Thank you, sir.
yes.
So we will now move on to the Q&A session. Participants will post questions in the chat box and we will proceed them one by one.
Hmm. Okay, so like wireless, yes. So wireless is a trend. So means so now the thing is like uh, first it is very costly, and then it is not means like uh, means we can see in India like means the first of the so sorry, the most of the electric vehicle are even mean the cost is very high. So means if we use this kind of technology in the EV now, so uh, uh, so our EV adoption will be slow. And then secondly, it is not means like uh, means it is not like proven till date. Means means it's like uh, means we require that that kind of infrastructure, means that kind of technology in at least in India now. Means if if the cost goes down, they can slowly push this kind of uh, tech, technologies into the Indian markets. Okay, and then okay, smart BMS now being connected to the cloud. Okay, okay. So means now means uh, now the smart BMS are being connected to cloud. Yes, okay. What are the most uh, critical vulnerabilities like it means now if uh, if means like if there is okay if the uh, if okay if the card is actually connected to the cloud in through the cloud, means someone can uh, uh, hack your server or anything. Means like such means like someone can hack your uh, server and then get the access of your card. So uh, so so means like means like some means someone driving, and then if you and then if a- and if the hacker tries to stop the car, so it can be a very da- dangerous situation. So means like such kind of situation should not occur. So means the yes. Okay. I will. Okay, so the so 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 if we compare the Kalman filter and the AI as a- as assisted model, so means means as per means about what I means about what I've checked is like we can get 90 plus percent accuracy over the SOC estimation. So for that dynamic load, but they this kind of thing actually depends on the parameters that we give it in. So means if the parameters are accurate, we can actually we can actually predict it even more. Means predict it more accurately. So, okay, okay then. Okay, what is okay, okay, okay. And one more quick question means in the SOH monitoring means how does the smart BMS account for the uh, different pattern means how how the vehicle is uh, means uh, driven driven. So means what we take is like we take in the voltage and the current and also the te temperature values of the cell um, and 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 then based on the AI model we can we can actually uh, give its give these values and also predict means how is it means how the means like uh, mean means what will be the health of the battery given the particular type of style what is driving. So so means if if the vehicle is driven at a very high speed, uh, then the currents are very high. The temperatures are are also getting too high. So so means we can tell that the SOC will go means the SOH will go bad. So on. So means we can use these kind of parameters uh, to to analyze the SOH of the cell. Okay.
Questions. So we have proceeded in
I
Once we conclude
I
today's
hope
webinar,
means I have answered.
we would like to express
Uh,
our heartfelt gratitude to Mr. Aditya Iyer for sharing his valuable time and knowledge with us. As a small token of our appreciation, we would like to present you with a certificate of gratitude from IEEE SISGS. Your session has helped us connect theoretical concepts with real world engineering challenges in electric vehicles.
We also thank IEEE SICC student branch and the organizing team for successfully arranging this session.
And a big thank you to all the participants for joining us this afternoon and making the session interactive and meaningful.
We hope this webinar inspires you to explore further in this field of electric vehicles and power electronics.
Thank you, everyone. See you at next session. Thank you.